Okay, YouTube, in my last video we defined the unit circle and kind of looked at how useful it is in evaluating trig functions. In this video, I'd like to actually explore, kind of pick up where I left off, explore even and odd trig functions, and that is we're going to explore primarily cosine and sine. But it's helpful to know the definition of the unit circle. So we're going to go ahead and start with the unit circle again and talk about, okay, so why do we call functions even or functions odd? But essentially, let's go ahead and discuss this unit circle again. Now the unit circle, we say, is the circle that is of radius 1 and it is centered at the origin. So forgive my sweet drawing skills because I've already kind of biffed that one. Let's see. Go, go, go. That's not bad. Anyways, I'll tell you what. The unit circle, the reason why it's so nifty is because if we had, say, some angle in standard position, we'll call this angle theta. Okay, we have theta here. Theta. We say if we had a point on the terminal side of this angle, we'll call this point x comma y. Okay, x comma y. Then we would say we'd have this right triangle here with dimension y and dimension x, and I'm going to take those out of there as a matter of fact. I don't want those in there in this video. But the fact of the matter is this. We'd say, okay, well, if the y dimension's y, and we'll call the radius of this r, and the radius is actually equal to 1, I'm going to take those out in a minute, then we could say, okay, so the sine of this angle would be y over r, in other words, y over 1, or just y. So the nice thing about the unit circle is, the fact of the matter is we say, okay, so all the points on the edge of the unit circle, the y values represent the sine of that angle. And likewise, we could go back and do this with x and r. We say, okay, so the cosine value of theta would be x over r, but in this case, you know, r is 1. So when I do x over r, I'm really taking x divided by 1. The essential consequence here is this. All the points on the edge of the unit circle are just cosine of theta. In this video, however, we want to kind of explore even and odd functions. So before I go any further with this definition of the unit circle, what I'd like to do is direct your attention maybe over here to the right-hand side. Well, let's go ahead and define what we mean by an even function. An even function is any function. Now we say we're going to use function notation here, f of x, okay, for which this happens to be the case. F of x, or a y value, is equal to the same thing as if you were to plug negative x into the function, okay? So an example of an even function in general, like in algebra, would be something like y equals x squared. So this is like a random example, but we say, well, y, it means the same thing as f of x. Of course, we know, like, if we meant like f of 2, good review here, f of 2 just means wherever I see an x, I'm going to take it out, I'm going to plug in a 2, I get 4, okay? But we say this is an even function because what if I were to take that x value and plug in negative that x value? So kind of like up here, we're plugging in a negative x. The question is, would I end up with the same thing as f of x, or just a plain old y value with the original x? And we say, well, this would be negative 2 squared, and I still get 4. So you basically, it pops out to be the same f of x value in both instances, but in either instance, we plugged in a positive or a negative x. So that's kind of a significant thing, In general, we could say, well, what if I plugged in a negative x wherever I saw an x? So that would be, well, we had x squared. I'll put in a negative x. But you know what happens when you square a negative thing? It just becomes positive again. I get x squared again. And that is the same thing, ladies and gentlemen, as f of x. So really the consequence here is we're saying this f of negative x and f of x, hey, you get the same thing. And that's kind of a neat consequence. So we say even functions basically mean this in general. If you were to say f of negative x here, you get the same thing as if you would have done f of x in the first place. So now, what would I mean by like necessarily an odd function? Okay, so let's go ahead and define odd. An odd function would be any function defined by this. If I were to do, say, f of negative x, okay, you actually get negative f of x. That negative, we could say, kind of, you know, look at it as it goes out front. It doesn't really do that, but we say, okay, so what would be an example of, say, an odd function? Okay, well, an odd function, in this case, we say, well, what if I were to make up this function y equals x? Okay, the bottom line is this. We could say, well, that's the same thing as f of x equals x. So, for example, we say, okay, so f of x equals x. What if I did f of 2? With 2, that was a good example last time. I would get everywhere I see an x, I'll plug in a 2, I get 2. So odd function means, well, what if we were to plug in a negative of an original x value? We say this x value right here, what if we plugged in a negative that into the function? So what if I now attempt to do f of negative 2? What I want you to see is this. you would plug in a -2, where you saw x, and you get -2. But that's the same thing. We could rewrite this as like saying, but that's like negative f of 2, because remember f of 2 was 2, and so that's like this 2 right here. We could say this is negative f of x, because when we did f of x we got plane 2, and this time we're getting negative that 2, so negative the original f of x value at that input. So essentially an odd function would be any function that where you plug in a negative x, you basically get negative of what you would have gotten if you had just done plain old f of x, just plain old f of x. So the two things you'll want to put in your notes are these. Well, even and odd, those are the definitions of even and odd, okay, functions. The thing is, though, I wanted to go back over here and look at the unit circle. And so, interesting thing, and let's switch colors here. What if I did this other angle? We're going to do it in like this, well, that's kind of conflicting. What about like a red-ish? Instead of like theta, okay, what if we had done negative theta? I'm going to try to draw this as closely as I can to this. If we had gone a negative theta rotation, that just means we would have rotated theta degrees or radians in this other direction, and we still would have had a point on the outside of this, and we could drop down in altitude, and you'll notice that these two triangles are nearly identical, except for in this case we'd have the point positive x comma negative y. Okay, so essentially we're saying, oh well, that would be the cosine and the sine value of this. Oops, I didn't want to do that, but like the cosine and the sine value of this excuse me, but this would be, in this instance, we'd say this is cosine of negative theta, because that's what we're evaluating this for, and this is sine at that angle, and that angle this time was negative theta. Interesting thing, though, is this. You're seeing that cosine of negative theta comes out to be x, and cosine of positive theta just comes out to be x. Okay. So what if we were to define our functions like this? We say f of x equals cosine of some angle, and that angle is x. Okay, or we could say f of theta equals cosine of x. We can look at this as a function now. And what I know is this. If I were to say plug in cosine of positive theta, it just comes out to be some plain old x. And cosine of negative theta, I'd get the same thing anyways. I'd get the same thing anyways. So the bottom line is this. If I were to do now f of negative x, okay, f of negative x here, you would get cosine negative x, but cosine negative x was the same thing you got as when you did cosine of x. So really, what this means, what makes this so profound is this, and really I circle this whole thing, but really I need to designate this part. We could say that cosine of negative x is the same thing as cosine positive x. It is an even function, because if you look back up here on the right again, when we plugged in a negative x, we would have gotten the same thing as if we had just plugged in a regular x anyways. So why do I care? Why do I care that cosine is an even function? And that's what you want to write down. Cosine is an even function. Cosine is even. Well, you want to write this down because if somebody said, now I want you to go find the cosine of negative 45 degrees. Since we're plugging in a negative thing into an even function, you're going to get the same thing as if you did cosine 45 in the first place. Why would I rather do this? Well, because this is positive. It's just more convenient. So whenever you take the cosine of a negative angle, you might as well just take cosine of the positive angle, because you're going to get the same stuff anyways. And just to illustrate this, we say, okay, so a unit circle, blah, blah. We say, here's my 45-degree angle, here's my negative 45-degree angle. So negative 45, negative 45, positive 45. We'd get this x here and this x here, because in the unit circle, recall that cosine is the x value. You'll notice that you're going to get the same x value no matter which way you go. And this is very poorly drawn, I understand that, and I apologize. But you get the same x value either here or down here. So the fact that cosine is even, it just means this. If you ever do the cosine of a negative angle, you might as well just do the cosine of a positive angle. You get to make that angle positive. It's going to come out to be the same thing. So now sine. Sine's a little bit different. We'll go back up here. We say, okay, so in this case, I got positive y up here and a negative y down here. But you'll notice that when I do y, it's the same thing as sine of theta. But when I do negative y, that's the same thing as sine of negative theta. So essentially, essentially what I'm saying here is this. Sine of negative theta would be the same thing as negative y, or negative f of x. So if we were to define our function now as f of x equals, say, sine x, that's our function. Well, what if I were to say, okay, so since this is odd, I'll just go ahead and tell you right now, cosine is an odd function. I know, you're already thinking that, I'm sure. An odd function. We could say then this, f of negative x, or sine of some negative angle, okay, would be the same thing as negative, just plain sine of the positive angle, okay? So since we did say sine of a negative angle right here, this negative theta comes out to be negative y, that's like saying, okay, well, when I do sine of negative theta, we could just call it negative of a plane old y, and a plane old y was equal to sine of theta in the first place. So what this means is sine of negative angle is equal to negative sine of the positive angle. It just means this. Whenever you're taking the sine of a negative angle, you can put the negative out front and just do it later and just do the sine of as if it had been a positive angle. So I'm going to try to hook us up with a new canvas here. And this time I do. It drives me nuts when I don't go opaque. So we're going to go ahead and drop in an opaque background. There she is. But essentially, let's go ahead and write down what we mean. What if somebody said, please and thank you, would you find the sine of negative 45 degrees? Because we're plugging in a negative angle, and sine is an odd function. What this means is we can just go ahead, function. We can take that negative and throw it out front. It's going to be the same thing as negative sine of positive 45. Okay, so we know the sine of positive 45. You can look at your unit circle. Sine of positive 45 is the y value at 45 degrees is radical 2 over 2. So we say this is going to be negative sine of 45, negative radical 2 over 2. It's just negative radical 2 over 2 is the sine of negative 45 degrees. And I'm going ahead and going back over to the unit circle. Look at this. If we were to go negative 45 degrees here, if you can see my cursor, negative 45 degrees, you'll notice that the sine value is negative radical 2 over 2. So here's all I need people to know is this. It's very, very true that cosine of a negative angle is just cosine of the positive angle. Just do the positive angle. You get to scrub out this negative here, just eliminate, because it is an even function. Eliminate. And if you do the sine of a negative angle, the rule is basically this. We'll just put the negative out front and do it last, and we'll just do the sine of a positive angle first. So I like cosine better. I like even functions because you just get to ignore the negative. But odd functions are bad. It just means that instead of doing sine of a negative angle, which who wants to think about clockwise rotations, we'll just do negative whatever we get when we do the sine of a counterclockwise rotation or a positive angle. Cheers.